Welcome to the product overview for the TangentBlue 3501 SPI and I2C cRIO module. Today we will be talking about the robotic and industrial applications and related capabilities of this module for SPI and I2C communication. We'll start by covering some examples of common applications of the SPI and I2C module, then we'll take a look at the circuit block diagram, and also at some of the backplane protection that the module provides for the FPGA. We will also show an example sensor wiring and quickly discuss how we would structure the LabVIEW code to implement an SPI or I2C sensor driver. In robotic and industrial applications, there are a variety of SPI and I2C sensors and devices that are used in conjunction with the cRIO backplane, including sensors like accelerometers, encoders, ADCs, temperature sensors, directional sensors, and servo controllers. Until recently, the best way to implement these sensors was to use a generic digital I/O cRIO module. Using a generic module and adapting code found on IPNet, it was possible to manage one or possibly two sensors using one module if you used external pull-up resistors for I2C. The TB3501 module is capable of managing all of these sensors simultaneously, while providing a driver architecture with a host-side programming interface based on standard bus operations rather than low-level FPGA code. As you can see on the front panel wiring diagram to the right, there are 6 chip selects for SPI devices that can each be configured for 3 or 4 wire operation. Sensor power up to 1 mA can be provided through any unused chip select line. The SPI bus voltage level is software configurable at 3.3 volts or 5 volts depending on sensor requirements. Clock speed can be configured up to 2 megabits per second, and all combinations of SPI clock phase and clock polarity are supported. For I2C operation, the TB3501 module includes programmable pull-up resistors optimized for I2C standard, fast, and fast plus modes. I2C sensor power is provided on a separate line, and bus voltage is also software selectable. The maximum number of sensors is limited by the I2C standard, which limits the total capacitive load on the bus. The hardware architecture of the TB3501 is constructed using 2 submodules. The base module provides the basic cRIO interface, including the module EEPROM, input Schmitt triggers, and digital isolation, and this board also provides front panel I/O and input protection, as well as module activity LEDs. This base module is also available as a separate product, the TB3001, for prototype module development. The second submodule is a circuit on the daughter board that provides the circuitry for SPI and I2C communication. In order to fully leverage single-cycle timed loops on the backplane FPGA, the daughter board contains a CPLD that routes message traffic to multiple sensors and indicates the bus status on the front panel LEDs. The driver provided with the TB3501 provides a basic programming interface for module management, including initialize and close VIs as well as a configure VI, which allows you to choose the mode, bus voltage, and communication speed. Also included with the driver are low-level read and write sub-VIs for communication with a communication protocol engine that runs on the FPGA. Example device drivers are included for a common accelerometer IC that demonstrates how to write a driver for your sensor using any of the supported SPI and I2C modes. As you can see here, the software architecture for I2C devices is very similar to SPI. The features that make the TB3501 module an improvement over a generic I/O device for SPI and I2C communication are the increased power, speed, and flexibility that the application-specific circuitry provides. Specifically, speed is optimized through the use of single-cycle time loops on the FPGA. Sensor flexibility is increased through software-selectable bus voltages and I2C pull-up resistors, and the onboard power supply for sensors adds convenience. By supporting all of the most common communication modes, as well as some common sensor-specific needs, such as variable bit length read and I2C clock stretching, the TB3501 provides an optimized solution out of the box. Also, the status LEDs on the front panel provide a convenient system diagnostic tool. For more information about the TB3501, including pricing, specifications, product manuals, and data sheets, visit www.tangentblue.com. For specific questions about the TB3501 or other TangentBlue products, including pricing, availability, and delivery time, contact TangentBlue via email at info@tangentblue.com or via phone at 402-237-8478.